One of the effective techniques of determining sample elements from a population is stratified sampling, because it proportionally divides the samples to the different groups or categories. This video will guide you how to stratify your samples to the different groups of populations. But before we discuss an example, we recall the concept. Stratified comes from the root word strata, which means groups or categories. Its singular form is stratum. The process involved in stratified sampling is dividing the elements of a population into different categories or subpopulation, and then the members of the sample are drawn or selected proportionally from each population. In this video, I'm going to discuss to you how to stratify your sample elements through stratified sampling. Example, during the enhanced community quarantine due to the COVID-19 pandemic, the provincial government wants to conduct a survey regarding the life experiences of the barangay residents through the municipal mayors and barangay chairpersons. To avoid bias in determining the number of residents per barangay, the surveyors will make use of the stratified sampling as a strategy. Suppose there are 10,000 residents in Town A with 5 barangays, namely B1, B2, B3, B4, and B5. How many residents will be considered per barangay if they need a total sample of 370 residents only? If you notice, there are only 2 given data here, our sample size here, which is 370, and our population size, which is 10,000. So notice that in the first column here, okay, the first column represents the barangay in Town A. It represents the barangay in Town A. We have B1, we have B2, we have B3, we have B4, and we have B5. So Barangay 1, Barangay 2, Barangay 3, Barangay 4, and Barangay 5. And our second column shows the population per barangay. So the population in B1 is 2,500. The population in B2 is 3,000. The population in B3 is 2,000. The population in B4 is 1,500. And the population in B5 is 1,000. So that the summation of all the populations here and sub-I, where I ranges from 1 to 5, is 10,000. The range is 1 to 5 because there are 5 different barangays. In the second column, it shows the proportionality of sample size based from the population per barangay and the population, the total population. So in the first barangay, B1, since our population in B1 is 2,500 and our total population is 10,000, we divide the population in the barangay by the population times the sample size. So we have 2,500 all over 10,000 times 370 is equal to 93. This means that we have to allocate this sample size proportionally to each of the barangays in Town A. So the allocation is based on the population per barangay. So we expect that the larger the population of the barangay, the more number of residents or sample elements to be considered. Okay? In the second barangay, the population is 3,000. Divide it by 10,000 times 370 will give us 111. And in the barangay 3 or B3, the third barangay, we have 2,000 divided by 10,000 times 370 equals 74. So we need 74 residents in B3. And in B4, we have 1,500 population divided by the total population in town A times 370 as our sample size equals 56. So we need 56 residents in B4. Lastly, our B5 is 1,000 population divided by 10,000 total population times our sample size, which is 370, equals 37. So getting the sum of these samples from the different barangays, the total of the samples in all the barangays is 371. So the summation of n sub I, where I ranges from 1 to 5, is 371. But the question is, we are only given sample size, which is 370. So in that case, we remove one, or we deduct one from the actual total of the sample size to the barangay having the largest sample size. So we have B2 with 111 sample size. So we remove one there, and we have minus 1 here to get 370, and to be the same with the required sample size that is being given in our problem. So we already solved our problem here. So we just remove one point, or one resident from B2 because it has the largest number of sample size. Okay? So again, we divide proportionally our sample size based from the population size of each barangay and according to the population size, total population size. The second example is the College of Information and Computing Sciences is one of the biggest college in the campus. Currently, it has 1,856 students who are officially enrolled in its BSIT program this semester. A research on the effectivity of online learning will be conducted. Given the margin of error at 5%, how many students shall be taken out of the total enrollees? Using stratified random sampling, how many students per year level will be considered given the population on the table below? So the first column is the year level. We have first year, second year, third year, and fourth year. The second column is the population size per year level. We have first year, second year, third year, and fourth year. So if we get the total of this, the summation of n sub I is equal to 1,856, where I ranges from 1 to 5. Okay? So going further, our given are the total population, which is 1,856, and our margin of error is 5%. So notice that there is no specific sample size provided in the problem. So before we can stratify our sample sizes or sample size to the different groups or categories, we have to determine first our sample size. First, so given our population size and our margin of error, we must have to use the formula n is equal to capital N here times the square of z sub alpha over 2 divided by the square of z sub alpha over 2 plus 4 times capital N times the square of E. Remember that your z sub alpha over 2 is the z-score when alpha is equal to 5% under the two-tailed test. And that is equivalent to positive negative 1.96. So by substitution, we have n is equal to 1,556 times the square of 1.96 all over the square of 1.96 plus 4 times 1,856 times the square of 0.05. And squaring this and multiply it by 1,856 will give us 7,130. And the square of this is equal to 3.8416. And the product of this is 18.56. And we have 7,130 divided by the sum of this one is 22.4. And that is equal to 318.30, or the sample size is approximately equal to 318. So in this, we are now ready to stratify the sample size to the different year levels. So we have sample size is equal to 318. Okay? So part B of the solution. Our first year level population is 620. And the second year level population is 550. The third year level population is 380. And the fourth year level population is 306. A total of 1,856. And our proportional sample sizes, we have here 106, the same step, 94, 65, and 52. And the total is 317. Okay? Again, since our sample size is 318 and we only have 317 here, then the solution is that we add 1 to the year level or sample size with the smallest value. So we found out that year level 4 or fourth year level has the smallest value. So we add 1 here to complete our sample size. Therefore, n must be equal to 318. So the purpose of adding 1 to the smallest, to the year level with the smallest sample size is to complete our acquired or required sample size, which is 318. So as a rule of thumb, we have if the summation of n sub I is less than n by 1, then add 1 to the stratum with the smallest n. But if the summation of n sub I is greater than n by 1, deduct 1 from the stratum with the largest n. Okay?